Hello everyone and welcome to our first video tutorial on ellipses. In this tutorial we are going to learn first the basic components of ellipses, and then from there we're going to go into writing an equation for a given ellipse. So here we have two ellipses, and as you can see they can have a horizontal orientation like the one over here on your left, or they can have a vertical orientation like the one on the right. We'll get into how to tell what ellipse will have what here in a minute. So, some components of ellipses. First, we're going to get into the vertices. Now, these are these points right here for the horizontal ellipse. And for our vertical ellipse, they're the points right here. Now, how you tell where the vertices are is the longer side of the ellipse, okay? The kind of the stretched out hot dog side. Your vertices are over here. In other words, the points with the distance greatest from the origin, so right here. Those are your vertices. Now, and these points over here. Now, you can also have a different set of vertices called co-vertices. Let's pick a nice color for those. Now these are the other vertices right here. Okay, and over here on our vertical, it's right here. Okay, and those are called co-vertices. Okay, so vertices and co-vertices. All right. Now, the vertices are the endpoints of what is called your major axis, or the longer length of the ellipse. So on your horizontal ellipse, it runs horizontally, and on your vertical ellipse, it runs vertically. Can't really see it on that black, but it runs right there. Okay, those are your major axes. Now, you have also what's called minor axes, and those are that's the axis from your co-vertices. So right in here, that is your minor axes. Okay. Now, the last thing that parabolas have that we're going to talk about is called foci or foci. These are points generally around in here. We're going to figure out how to tell where exactly the foci are. And on your vertices, they will be on your major axis. Okay, and this is a component of the ellipse that gives it its shape. Okay, so standard form of an ellipse is given like this. It is for a horizontal orientated axis. It's given as x squared over a squared plus y squared over b squared equals 1. For your vertical axis, it is given as x squared over b squared plus y squared over a squared equals 1. Okay? Now, a and b and blah, blah, blah. Where do you find that out? Well, what's nice about this is that you can extract a and b right from your major and minor vertices. Okay? So, in both of these matrices, the major axis equals 2a. Your minor axis, minor with an N, equals 2b. Okay? So, that is how you would figure out your A and your B. Okay? Now, there's another definition, and that comes from your vertices. Okay? Now, on this ellipse over here, your vertices will be given as negative a, 0, and a, 0. Okay? Your minor vertices will be given as 0, negative b, and 0, b. Okay? I know this is a lot to take in, but trust me, with practice, this will come like a snap. Now, over here, your definitions are a little different. Here, your minor axes will be negative b, 0, and b, 0. Your major axes will be negative a, 0, and a, 0. Or excuse me, flip those around. Let's erase that. Isn't that fun? Okay. It'll actually be 0, negative a, and 0, a. Okay. Last thing, your foci, or your foci. They can be plus or minus c, comma 0 for your vertical, or excuse me, your horizontal ellipse, or they can be 0 plus or minus c for your vertical ellipse. So this is for horizontal, and this is for vertical. Okay? So, in the next video, we'll get into an example of graphing an ellipse. This right here, this video just gives you the parts and components of an ellipse.